Okay, we're going to do a quick little warm-up, refresh your memory on domain and range. So your domain is your input values, or your x's, which in this set of ordered pairs you have 0, 1, and 2. And then your range would be all of your output values, or your y values. So you would have just 0 and 2. And that should definitely be a squiggly brace, not parentheses. Don't know what I was thinking there. And it is a function because even though it has a couple of the same output values, none of the input values are repeated. So we're going to talk about alternate ways that you can write inequalities today, or express like a range of values instead of individual ones. And that is called interval notation. So if I was to write the set of numbers that this number line represents as an inequality, it's all of, I'm going to use x for my variable, all of the numbers between -1 and 1, so x is greater than or equal to -1 and less than or equal to 2. In interval notation, this would look like square brackets with your smallest value of your number on the left and the biggest on the right. It's called a closed interval because in this case it contains our two endpoints of -1 and +2. Next one's pretty similar, except you have open circles, so your inequality isn't actually numbers equal to -1 or 2. In this case, you use parentheses instead of square brackets, so if you don't include the number at that end, you use a parentheses instead, and it's called an open interval. Kind of matches your open circles. You can have one where it contains one endpoint, but not the other. So if I was going to do an inequality for this one, it's greater than -1, can't be equal to it, so I have parentheses at my -1, and then it does include the 2, so I'd have 2 with a square bracket. And then the next one's just flipped around, so whatever value is included has a square bracket, and whatever value is not included has a parentheses. Those ones where it includes one endpoint but not the other are called half-open intervals. Sometimes your set of numbers continues forever in one direction, like this is all the values that are greater than -1. So bigger than -1 forever and ever and ever and ever is approaching infinity. So my interval starts with the littlest x value really close to -1 and then goes towards the bigger numbers at infinity. On infinity, since it's not actually a number that you can like stop at or include, it's always going to be a parentheses. Those are called unbounded intervals if they continue forever in one direction. This one's a less than or equal to 2, so it's going downwards towards the negative infinity forever and ever and ever. So when you write it order-wise, you should always have your smallest value on the left side of your interval and the biggest on the right. And you can have intervals that contain two separate sets of numbers, like this is all the x values that are less than or equal to -1 or greater than or equal to 2, kind of like when we solved our absolute value inequalities. So you can join two intervals together using a union symbol, which just looks like a U. That means all the numbers in either one of those intervals. We're going to practice our interval notation by writing some domain and range. So if I'm thinking about the domain, it's all of the possible x values that are covered by my function, or relation, depending. So I could list out some points here and think about what x values they contain. If you look at your line, it's connected, so I can't actually list out all of the x values individually. That's why I need interval notation. My x values stretch left and right as far as my relation goes. So in this one, my littlest x value is -3, and my biggest is +3. So my domain is from -3 to +3, and I do have points that include -3 and +3, so I use square brackets. For my range, I am thinking about my y values. So if I look how far my y values stretch vertically up and down, so thinking about how far my y values go from like bottom to top of my line on my relation, or curve on my relation, I've got a smallest y value of it looks like -3 and a biggest y value of +3. And that's part of my line, so those are going to be included. There are actual points there. So my range is actually same as my domain, except it's my y values. They stretch from -3 to +3. Let's look at this horizontal line. So if you think about the points along this horizontal line, I could list them out here. If you look at this horizontal line and think about its x values, this horizontal line never stops, and there's an infinite number of x values going towards -infinity and +infinity, continuing forever and ever left and right. So my domain's going to be -infinity to +infinity. For my range, I just have a single y value, so it's just going to be 2 by itself inside my squiggly braces, because that's for individual disconnected values. You can't use interval notation or with brackets and parentheses for those. This one here is a bunch of individual points, so I'm going to go ahead and list their coordinates out. Makes it a little bit easier to think about what input and output values you have. So for your domain, you've got -1, 2, and 4. Again, those are individual disconnected values, so I'm not using interval notation. We don't have all the x values in between like -1 and 2, just those 3 individual ones. And then range is kind of similar. We have 0, 3, 4, and 5 for your y values. I didn't answer this as each a function yet, so let's go back and do that. If you look at the circle, it is not a function because you have points that have shared x values. It doesn't pass the vertical line test either. B, your horizontal line is, and C is not because you have those 2 points that have the same x value, 2, 3, and 2, 0. I don't necessarily need you to be able to sketch the shape of every function, so let's use Desmos here to graph these, and we can use our graphs to figure out our domain and range. So if I'm doing a plus or minus square root of 2x plus 3, that means the positive one and the negative one, so actually to graph that in Desmos you have to type 2 separate equations, and make sure both your 2x and your plus 3 are inside your radical, not one of them outside. It should look like this. So if you're thinking domain and range, like your domain, if I zoom out here, it looks like it continues to the right forever, and your smallest x value is -1.5. So our domain is going to be from -1.5 with a square bracket because I have a point that actually has that x value to infinity. And then my range, it's going vertically expanding out slowly forever and ever, so -infinity to infinity, and it is not a function. B is a trig function. We've got cosine, so under your functions menu you can pick cosine, and then if you look at it, cosine has kind of a fun graph. It is wavy, bounces back and forth, up and down. So your domain, left and right, it stretches on forever and ever and ever. So from -infinity to infinity is going to be your domain. Your range, you're going to want to think about your y values up and down vertically. What's your lowest y, your highest y, and they go from -1 to +1. And yes, it is a function. No shared x values on any of those points. Passes a horizontal line test. Let's sketch a function that meets some requirements. This might take a little bit of playing around here, but our domain's supposed to be from -4 to infinity, so like on your x-axis it can only go back to -4, should continue to the right forever. And then your range is supposed to be from -infinity up to 3, so like your function kind of has to fall in this box right here. So let's see if we can sketch one. There are a lot of possible options. It does need to be a function, so make sure it passes a vertical line test. I'm just going to start there, bounce back and forth a little. Oh, I need to make sure it actually goes up to 3. But that's a parentheses, not a bracket, so it actually needs to not include 3. and then it needs to go down towards negative infinity for my range to be correct.